In the previous video, you saw how trying to solve the problem of turning these lines into these interactive XAML elements eventually broke down. The main problem was that at the point where we needed to handle the user event of clicking on the flashcard question, we didn't have access to the flashcard answer since our code was not organized into objects. We then considered storing our variables globally so that we could access them anywhere, but this introduces the next problems of variable naming conflicts and making it difficult to share functionality in an organized way between the objects. The solution to this problem, of course, is to recreate the application using an object-oriented approach from the beginning, which is what we're going to do in this lesson. So now let's solve this problem with an object-oriented approach. Go ahead and open your Visual Studio, new project, and WPF application. In the XAML, go ahead and change this to a stack panel with a margin, and inside a stack panel, give it a name of main stack panel. And now, these are the lines that we need to parse. But instead of iterating through these lines and just picking them apart, we're going to iterate through the lines and instantiate objects. The object that we'll instantiate will be called question. We'll create it in a minute. But right now, let's just say question, and then we'll say create, and we'll send it the line. So let's go ahead and create the question object, or the question class, so we can instantiate a question object. And we'll do that right here. Public class question. And inside the question class, we're going to make a static method to instantiate it. Like this. And with the static create method, we're just going to return a question. So we'll say return new question and just send on the line. And of course, we need to create the constructor. CTOR tab creates the constructor. We need to say string line. And we'll take that line and save it internally in the question. Here we'll have private string and underscore line for private fields. And then here, save line to line, like that. And I see here this needs to be a large question. And I could have here just instantiated the object like this, but you'll see in a minute why I have the static create method to do that. But if we run this now, it compiles, but it doesn't display anything, which is what we need to do next. So let's say here, main stack panel, children, add, and we're going to tell this question that we created here to render a control that displays it. We'll call it RenderControl. And that doesn't exist yet, so it informs us of that and gives us the opportunity to create RenderControl. And if we go down here, we see that we're returning a UI element, which is exactly what we want to do, because that's going to be added to the stack panel. And all we're going to do here is say, create a text block, fill it with a text. For instance, this is a question. And then return the, not text box, but text block. Like that. So if we run this, we indeed have 5 questions being instantiated, and they're all being displayed with RenderControl. So that's the beginning. Now we need to create a class for each of the types of questions that we have: a flashcard, multiple choice, and a TrueFalse. So let's do that right down here below question. Here's the question class. And we'll say public class flashcard inherits from question is a kind of question. And the same with public class multiple choice is a kind of question. And public class TrueFalse is also a kind of question. Now, when we say question create up here, we want it to, yes, create a question, but even more precisely, create a flashcard or a multiple choice or a true-false. So that's what we need to do now. We'll go in our create method and we'll change this. So we have the line coming in, and in the line we know that at the beginning of flashcards it says flashcard semicolon, and at the beginning of multiple choice it says multiple choice semicolon, and at the beginning of true false it says true false semicolon. So let's put that in if statements here. If line starts with flashcard semicolon, then return new flashcard. Else if, and it's getting a problem here. And the problem is it doesn't have a constructor, which we'll put there in a minute. But let's complete this block. So, else if line starts with multiple choice, semicolon, then return a new multiple choice and pass on the line. Else if line starts with true, false, semicolon, then return a new true, false, and pass on the line. And we can say else just go ahead and just return a question, and I'll show you how we can handle that in a minute. So what we need to do now is create these constructors. What it's saying here is flashcard does not contain a constructor that takes one argument, so we have to add that. And a constructor is, for instance, this here. Class question, question line. So when you say new question, as we do here, where is it? Question create, yeah, new question line. That's what creates or constructs the object from the class. So what we're going to do is do the same thing for flashcard. So we're just going to say CTOR tab, and it has to accept a line. And then we're going to say, just go ahead and call the base constructor. The base constructor is the constructor in the inherited class. And it tells you here that is question, which is right here. And we'll do the same thing for multiple choice. So create a constructor, accept the line, and pass it up to the base constructor, which is question. And for true false as well. Constructor, accept a line, pass it up to the base constructor. That's all we need to know. So what will happen if we run it now? Now that it's creating flashcards and multiple choice and true false, and then calling the render control on question. Let's try it. And it's the exact same thing, because we instantiate, for instance, a flashcard with the first line, which is, for instance, here. Now this variable question is actually a flashcard, and then we call render control on it, and render control just prints this out. Now if we debug this, let's go up here to question, we'll see what's happening. So run it, and we are here at this statement. It's about to instantiate the question, so I'll press F11 to go in, and we see that it is in the static method create in the class question, which is where we sent it. And as I go down with F10, because line starts with flashcard, it gets into here, and now it's going to create a flashcard. So we'll step into that with F11. And now the flashcard is being instantiated, but if I press F11 again, I see that it is calling the base constructor, F10. This is null, F10, and now this is the line, which defines the flashcard. So we have now come back to the constructor in flashcard, and the flashcard has been created, and now we are out of constructing the question variable, but the question variable is actually a flashcard. It's a flashcard, but it's also, if you look in here, the base of it, or its base, its inherited class, is a question. So first and foremost, it's a flashcard, but it's also a question. So let me press F5, F5, take this out and F5, and it creates it. So now if I set the breakpoint here and run it again, we have the same thing. I have a flashcard object. And now if I press F11 to step in, I'm in RenderControl. In what? In the question. Why? Because question has a RenderControl method and flashcard does not. What it actually did is it went to flashcard and said this object called question is a flashcard, and I have to call RenderControl. So it tries to call it on flashcard, but there is no RenderControl in flashcard, so it calls it on the base class, which is RenderControl in question. So what we want to do now is in flashcard, we want to put in a RenderControl, so that a RenderControl method, so that if it's a flashcard, it'll call the RenderControl method in flashcard. If it's a multiple choice object, it'll call the RenderControl method in multiple choice. And if it's a TrueFalse object, it'll call the RenderControl method in TrueFalse. This is called method overriding in object-oriented programming, and it's where you get a lot of the functionality that object-oriented programming offers. So let's see how this works. I'm going to go ahead and take this RenderControl method, which is in question, and I'm going to make it virtual. And I have to stop the execution here. So now this method is virtual, which means it can be overridden. I'm going to override it in Flashcard. And Visual Studio makes this very automatic. I type internal, override, space, and I find RenderControl. I hit enter, and it creates the whole method for me and allows me to change it, which I'm going to do by going here, Control C, and just copying that text in there and say this is a flashcard. So let me run this. F5 to continue. And I see here that in the objects that have a RenderControl method, that RenderControl method is being executed, for instance in Flashcard. But in MultipleChoice and TrueFalse, since they don't have a RenderControl method, they're just passing up the responsibility to their base class, question, and saying, I don't have a RenderControl method, you use yours, please. And that's why these say question. So let's go ahead and do the RenderControl methods for MultipleChoice as well. Internal override RenderControl, and we'll copy this in. MultipleChoice, and the same thing for TrueFalse. Internal override RenderControl, and copy this in. Now each of these three classes which inherit question have their own RenderControl methods, which we can see when we run it, that they each are executing their own methods and not the method, the virtual method in question, their inherited class. So this gives us a chance to handle the case where the user mistyped flashcard or MultipleChoice or TrueFalse. So we say here, return a question, and if it is a question, meaning that it's not one of these three, then it'll call the RenderControl method in question. So here we can say bad syntax in line, and then show the line. This here is a private field, which is defined here in the question, contained in the question object, and being defined in the constructor. So when we run it, all of these are okay. But if we change one of them, put an X in here for instance, then we see that it says bad syntax in line with an X in here, and we see why the flashcard object wasn't created. So that's a way to use method overriding to handle errors. But so far we've done with object-oriented programming everything that we did in non-object-oriented programming. We haven't gotten to the point where object-oriented programming has benefited us. And that point, remember from the last video, was where we tried to define the event in Flashcard, the event that the user clicks on the question. And in handling the event, we didn't have access to the answer text block in order to make it visible and invisible. So let's go ahead and move on to that. Here's how we do it. In Flashcard, in RenderControl, instead of just saying this is a flashcard, we want to print out the question and the answer. So first we need the question. Now, since every question has the question text in the second position, flashcard, multiple choice, and TrueFalse, we can define that in the question constructor, because flashcard, multiple choice, and TrueFalse all call the base constructor. So we can say here, we have to say parts, which is a string array, equals, and we'll split up the line, of course, on the semicolon. And this should be private field, so we'll make it that here, like that, so that everything is contained inside the object. Now, we want to say that here, private question text, which also has an underscore because it's a private field. So question text is what? It is parts and the second part of the string. So that would be, for instance, this here. Now, question text is defined in class, so it's also available in the flashcard. So what we can do here is call this in the flashcard TB question and use the renaming refactoring feature here. And then say here, question text, it's not available. Even though I'm in flashcard and inherit from question, I don't have access to this variable. That's because it's private. If I change it to protected, that means that even the classes that inherit from question have access to it, which you'll see here. If I do control space, I now have access to it. So now on the flashcards, it displays the question. Let's go ahead and fix that second one here so that works as well. All right, it displays both questions. So now we're getting close to the point where we broke down in the non-object-oriented example. So we are at the flashcard here, and we're defining what control gets rendered. Now we also need an answer text block. Text block answer equals new text block, and text block answer equals what? Well, it's going to be answer text. Now, where do we define this? Answer text, answer text is the 1, 2, 3, the third item here, but in multiple choice, this really isn't an answer text. That's going to be like answer 1, 2, 3, and 4. So it doesn't belong in question so much, it just belongs in flashcard. So I'm going to put it here, say private string answer text. And this means that I define it not in the question constructor, but in flashcard constructor. So I say parts. Oh, I don't have access to it. That means I have to go up and change parts from private to protected. So I have access to it in flashcard, the class that inherits from question. So I just pressed control space there and got parts. And what I really want to do here is answer text equals parts. And it's the 0, 1, 0, 1, 2, index 2 that I want to get out for answer text. So now I have answer text defined inside my object, inside my flashcard object, and I can use it here. So I need to say here text. So now I have answer text. Now instead of sending back the TB question, I'm going to make a stack panel and put both of the questions in them. So stack panel sp equals new stack panel. And then here I say stack panel children add the TB question and stack panel children add the TB answer. And now I pass back stack panel. So now let's see what we have. We have the question and the answer. Question and the answer. The next step, of course, is to make the answer invisible. So we'll say here TB answer visibility equals visibility collapsed. Hidden means that the space would still be there where it was. Collapsed means that it's taken out of the visual tree. So now we can run it again. And we see that they aren't there visually, but they actually are there, the answers. And we can make them be visible again by handling a click event. And this is where it gets exciting, because this is where object-oriented programming starts to pay off. Because I can now say TB question, mouse down, tab, tab. Now what I need access to is TB answer. And I don't have access to it, but what I can do, because I'm in an object, is I can put this TB answer inside the object. Private text block TB answer. And that means here, this is TB answer, and this is TB answer, and this is TB answer. And because it's inside the object now, this is also TB answer with an underscore. Now I have access to it. TB answer visibility. Okay, I'm clicking on it. So that means the visibility is now visible. So let's see if this works. I click on what color is the sky, and I get blue. I click on what color is the sun, and I get yellow, and that's very nice. We can also add a cursor here, TB question, cursor, cursors, hand. So that turns into a hand. So we also want the ability to, if I click it again, that it closes back up. And because we're using an object-oriented model, new features like that are very easy to implement. I'll show you how here. So this handles the mouse down event. I'm in here with the mouse down event. Sometimes we want to, if it's visible, we want to make it invisible. If it's invisible, we want to make it visible. So inside the class, we just make a private Boolean answer is visible equals false by default. And then we can say here, if answer is visible, then collapse it. Else, I'm doing Control C, Control V, else make it visible. And of course we need to switch this. So answer is visible becomes its opposite. So if it was true, it's false. It's false, it's true. And now we run it, and we can click them open and closed. Great, so this is working well. Let's move on to TrueFalse. Now let me show you a little magic that's going to happen here with TrueFalse, because we're using object-oriented programming. Because TrueFalse is very much like Flashcard, it also has a question and an answer here. We're going to, instead of inherit from question, inherit from Flashcard. So let's see what that does. Okay, it still prints this. What if we were to take that out? What would happen then? When TrueFalse has to render its control, it's going to say, I don't have a render control. I'll let my base class do that. And the base class is Flashcard. And the render control in Flashcard is full of functionality. So let's see how that works. The sun sets in the west? True. So it already works. TrueFalse is done. And just to show that TrueFalse can inherit the functionality of Flashcard, yet also extend itself with its own functionality, what we'll do is we'll say in Flashcard, we'll put at the beginning of the question that the user should answer true or false. And the way we do that is just by saying question text equals true or false question text. So question text is being defined in the question here. When true-false is being constructed, it calls this constructor first. Then it calls the Flashcard constructor. Then it calls the true-false constructor, which changes the question text. And the question text is what is being displayed in RenderControl and Flashcard, but which is used by true-false. And so question text will be assigned to the question. The result is that we have all of these working, but true-false questions have this appended on them and work otherwise exactly like flashcards. So now I want to show you that we can define multiple choice to have a completely different kind of render control or display while sharing some functionality through the common base class question, which Flashcard, TrueFalse, and MultipleChoice share. So let's do that. What we need to do is save these answers internally in MultipleChoice. So they will be like this. Private string answer 1 text, Control-C, Control-V, Control-V, Control-V. So we'll have answer 1 text, answer 2 text, answer 3 text. And then in the constructor itself, we'll define this. This will be a lot like this here, so we'll just copy it. So answer 1 text is going to be 0, 1, 2. That's correct. What I'm referring to here is here. 0, 1, 2 is the first answer. So I'm doing Control-C, Control-V, Control-V, Control-V. So answer 2 text, answer 3 text, answer 4 text, and this is 3, 4, 5. So now internally in the multiple choice object, the 4 answers have been defined internally, and now we just need to display them. And we can basically copy all of this from Flashcard into the render control for multiple choice. We can take the cursor off because it's not going to be a click. We just want to display it. And TB answer 1, we'll call it. Since we're just displaying them, we can define them here. Text block TB answer 1. And then TB answer 1 text equals answer 1 text. This we don't need here. This will copy 3 times with Control-V, Control-C, Control-V. And we just need to change all these. This is 2. This is 2. This is 3. This is 3. This is 4. And this is 4. And now we need to display them all. So TB answer 1, 2, 3, and 4. So that's all being done in multiple choice object. If we run it, we see that they are indeed being displayed. And we still have the individual functionality in these others. So one more thing I want to show you. Let's say we want to add a margin to all of these. We can, of course, put it in the base class because they all need the same margin. So let's do that. Here's the base class question. And what we're going to do is, since all of the render controls return a stack panel, we'll just say, instead of returning the stack panel, return adorn stack panel and send the stack panel. And where we're going to put this, we can even create it here. It'll create it in where we are in Flashcard, but that's not where we want it because we don't want just Flashcard to use it. we want Flashcard, MultipleChoice, and TrueFalse to use it, and they all inherit from question. So we'll put this in question. And then we want to return a stack panel that has a margin. So we'll take this stack panel here and add a margin to it. The margin equals new thickness of, let's say, 5, and return the stack panel. So now, okay, I'm seeing here that Adorn stack panel is inaccessible due to its protection level. It's private, and it's being called from a inheriting class here, which means we have to make it protected so that the inheriting classes can use it. And now it's okay. And we'll copy this, and we'll use it in MultipleChoice. And since TrueFalse uses the render control of Flashcard anyway, that's all we have to change. And when we run it, we see that each of them have the same margin. They all still have their individual functionality and the individual way in which they display themselves with render control. So in this lesson, I showed in a concrete example why you want to learn and use object-oriented programming. 1, it simply enables you to solve problems you couldn't solve otherwise. 2, by allowing each object to keep its own internal state in private fields, it allows the code to remain straightforward, even as the problems tackled become more complex. And 3, through method overriding, objects can inherit some functionality from base classes while redefining other specific functionality, which is an efficient method of code reuse. As a C# developer, having a solid grasp of object-oriented programming will allow you to make robust and scalable applications that you would not be able to create otherwise.